My name is Ben Overland. I'm from Swansea University. I'm just going to be showing you quickly how to take an eDNA sample from a water body. So if you don't know, eDNA, or environmental DNA, refers to the DNA that's released from an organism, an animal or plant, over the course of its life into its surroundings. So we're constantly releasing eDNA through our skin all the time. The same thing happens in an aquatic environment with all the species that are in there. So we will use a fine filter. We use a 0.45 micrometer filter pore size to draw water through, and this will trap all of the fine particulates, including eDNA, and we can then extract this, clean it up, and then use it to identify all of the organisms that are responsible for producing that DNA. So I'll just quickly show you through the kit that we will need. So we have a means of collecting a litre of water from site. So we use a whirl pack. These are great because these are sterile, but you can also use a litre bottle, although it's important to sterilize this between sites. It's easy to contaminate eDNA because it's such a sensitive approach. So we'll make sure everything that we share between sites is completely sterile. We have the filters themselves. As I said, we use 0.45 pore size. These are PES filters. The filter casings we use come in two pieces. So these are easy to put together in the lab, and then these can be autoclaved before we use them. We need a 50 milliliter syringe. These have a threaded lock so that they connect to the inflow of the filters. We have a preservative. This is just molecular grade ethanol. We don't need a full 10 milliliters, but this is just a single use, easy to use syringe. And these locks then to just seal in the DNA and the preservative when we've finished. eDNA is great for sampling species that are rarer or cryptic that aren't usually picked up in traditional survey methods. Let's start by taking up a sample of water. These whirl packs hold over a litre of water. You can get ones that are self-standing, but I'll just study this in a beaker. So now I'd open up a clean syringe, but I've got one here, so as not to waste it. And draw up 50 ml of the water. We'd then open up our clean filter and attach it using the lock. And then we slowly empty this through the filter. Now this will pick up all of the DNA in the sample, but also all the fine particulates in the water. We sample 1 litre at a time in replicates of 3. So when that's the first 50 ml has been passed through, we'll take up the next 50 and repeat until we've gone through all of the water. Might be easier at this stage to record how much the volume that you've gone through. so you know when you've hit a litre. So you'll keep repeating this until either you've reached your sample size, which in this case is a litre, or it becomes too hard to push the water through the filter. At that point, you know that the filter's clogged and we'll replace it before continuing with the rest of the sample. So I've just put 100 ml through there, but say that we've finished. The next step is to, dry the filter. So we'll just fill the syringe up with air and push the air through until there's no more water droplets. At this point we can add the preservative. You don't need to add the whole volume of preservative here, you just want to push it through until you get a bead at the top, and then you know that you have enough liquid and it's covering the filter. So this is then ready to be sealed. And then this can be stored in a cool, dry place, ideally at -20, until extraction at the lab. It's important to remember when taking any eDNA to take a site blank. This is just a replica using ultra pure water or autoclaved water, and this will just identify whether or not contamination is present in the sample. So we will repeat the process exactly the same as we did with the sample water, but using this clean water instead. Then when this is taken to the lab and analysed, we know that if there's any organism present in this, then contamination has occurred and we need to repeat that site. eDNA provides a great opportunity to sample rare species, but it is important to maintain cleanliness. So everything that we've used, we'll have to clean with 10% bleach between sites. That includes our waders, and we need to make sure that we change our gloves to ensure cleanliness. So eDNA isn't just used at sites like these. You can use it for sampling fish farms. You can use it to identify the presence of parasites in a salmon enclosure.